Okay, so more factoring methods, and this is method number 3, a perfect square trinomial, or sometimes called a trinomial square. Now we can get this if we take a look at this, and if we have a squared plus b squared, which is the same thing as a plus b times a plus b, if we multiply this out, a times a is a squared, and we use the FOIL method, inside b a, which is ab, outside ab, and then the last terms, b times b is b squared. We can see that we have the inside terms are the same, so we can add these up. We have 1ab plus 1ab is 2ab, so this actually multiplies to give this. So we actually say that we can factor this. If we go backwards, if we see something in this form, it factors to be this. And the same thing with a minus b squared. That's the same thing as a minus b times a minus b. And if we use the FOIL method, a times a is a squared, and then inside minus ba, which is the same thing as ab. Okay, and then outside, inside, outside last. Oh, outside, inside last. Excuse me. So, outside, AB, inside, AB, negative AB, and plus B squared. And once we take a look at this, then we can combine these. We've got a squared minus 2ab plus b squared. Okay? So sorry if I did the FOIL method in the other example in the opposite, wrong direction, wrong order, excuse me. So it's usually the FOIL method, F-O-I-L. I guess I should write that down just for some of you that forgot it. FOIL. Okay, the first terms, a times a is a squared. And the outside terms, negative ab. The inside terms are negative ab also, which is negative ba, which is also ab. They're the same. And then the last terms, positive b squared, and negative b times negative b is positive b squared. So that's our FOIL method. I think on the first examples I might have kind of reversed the order, but it's the same thing because the terms usually cancel or add up to be double in this case. All right? So there's our form. So now we know we're going backwards, so we know that a minus b squared is a squared minus 2ab plus b squared, or a plus b squared is a squared plus 2ab plus b squared. So we identify these forms. So if we see something where you have a perfect square as a first term and a positive perfect square, they both perfect squares have got to be positive. The square root of a squared is a, and the square root of b squared is b, and these signs are positive. Then do we have twice the product in the middle? And we do. 2 times ab, the product of is a and b is ab, and twice that's 2ab. So we've got that in the middle, so we know that that's just going to factor to be a plus b squared. Okay? It's a little bit bigger. All right? And then if we've got, again, if we look at this, the square root of a squared is a, the square root of b squared is b. And if we factor this, or if we notice this, we do have twice the product in the middle. Yes, we do, because a times b is ab, twice that's 2ab, except we have a negative, so that's going to determine the sign. So we just put these numbers here, a minus b. There you go. Okay? So here's some examples. It's very easy as long as you can identify your perfect squares. I think we had a little bit of practice on that on the difference of perfect squares. So let's take a look at example 1. And again, x squared is a perfect square. The square root is x. 9 is a perfect square. The square root is 3. Do I have twice the product in the middle? Yes. 3x is the product. Twice that is 6x. So I do have twice the product in the middle. So this follows the form of a perfect square trinomial or a trinomial square. So I know it's just going to be, this is the sign that would be in the binomial. If this is positive, it's positive. If this is negative, it's negative. These signs have always got to be positive or it doesn't work. If this is negative, it won't work. So the signs on the square terms have always got to be positive. So positive square, and we got a plus in the middle, so I just put x and 3. Okay? And over here, again, I look at this, I have a trinomial. It's got to be a trinomial. And I got a positive square term first and a positive perfect square last. And the square root of 25x squared is 5x. And the square root of 1 is 1. And 5 times 1 is 5, or 5x times 1 is 5x. Do I have twice that in the middle? Yes, I do. Twice 5 is 10. And again, these again have got to be positive, but this could be either way. In this case, it's negative, so I know there's going to be a negative between my terms, and it's going to be just these little numbers, which are the square roots, 5x and 1. That's how you got to do it. Okay, look at example number 3. And again, perfect square, positive perfect square, 4x. Positive perfect square, 3, because it's got to be positive. And what's 3 times 4? 12. What's twice 12? 24. So I do have twice the product in the middle. So this sign is positive, so that's the sign that goes here. And just these little numbers. Okay, and the last one. Square root of 64 is 8, so this is 8x. The square root of 9 is 3, and the square root of y squared is y. And if I take the product, I get 3 times 8 is 24xy. And what's twice 24xy? 48xy. So I do have twice the product in the middle. These again are positive perfect squares. They must be positive. And then this is negative. This could be negative or positive, and that's the sign that goes here. So in this case, it's negative. So I've got 8x minus 3y squared. And if you multiply 8x minus 3y times 8x minus 3y, you will indeed get this. I hope that helps.